we tend to forget. Especially I talk about the cover page during the class. Okay. Then after the class, then we finish our class usually at 6:30. Okay, and then sometimes it's almost to the my prayer times, and then that's why sometimes I forget. So if you check the Moodles, okay, later at night, and I still not uploading the cover page for your individual project, just drop me a message. You can ask a few of you, okay, messaging me, okay, saying that I forget, I didn't upload the sample document yet. Okay, I go and upload. Okay, I admit that I forget to upload that sample. So I already uploaded. You can find it also inside the Moodles. Okay. So now let's proceed. Let me start our class. Any questions? You may ask in the class, during the class. Okay. But of course, let me finish explain first. Then if you still have any questions, you can ask the questions. Okay. So here we go. Chapter 8. Okay, when we goes to the chapter 8, that's mean it's our last chapter for this semester. Okay, it's our last, okay, our last chapter for this. Okay. Okay, so we should start lah, we should start. Did you hear something?
Yes, miss.
Oh, this time around you can hear, right? It's not I'm the only one who hear that. I also hear something, guys. Okay, please mute yourself, guys. Mute yourself because we don't want to disturb other people. So, okay, other students who want to study. So please mute yourself. Okay. So we once said that don't harm the meeting. Okay. Okay, guys. Let me start. So we can hip hip hooray first. Okay. Hip hip hooray for the last chapter that we had. Okay. Actually, who is unmute? Because nowadays they didn't show. Microsoft Team have a lot of updated, and then sometimes it's make difficult. Okay, it made us difficult. Okay, let me proceed. I hope there is no interruption anymore. Okay, so we can hip hip hooray for a while. Okay, that's mean that even though your topic for the module already done, finished today, doesn't mean we don't have anything to do. You still need to have you still need a lot of exercise to do, especially for your lab test too. So next week we will learn tutorial for today's topic, along with starting with the exercise for your lab test 2. You know that your lab test 2 will be held on week 12 during the lecture session. Okay, most probably the timetable will not change. So our lecture will be on Thursday as usual. Okay, so let me start. So chapter 8, object-oriented programming. So okay, so in programming language, we always have this object-oriented, especially the nowadays, programming language, such as C++, Java. So we have this object-oriented programming. So what is the object-oriented programming? So let me look into it. Okay. Okay, so topic that we will cover in this object-oriented is what is object-oriented, what is classes and objects. So when we say object-oriented, it's always related to the object and classes. So in our, okay, in our situations, okay, sprite can be a classes and sprite also can be an object, okay, for our languages, our visual languages, the snap, scratch or BYOB. Okay, the object-oriented programming concept and terminology. And we remove, it's not object-oriented and BYOB. I already added actually, so some of them is a visual, okay, is a visual, okay, visual programming. So it's for all three lah, BYOB, Scratch, and Snap. Okay, so object-oriented in other programming language. So it's not only that we have the object-oriented in BYOB, we also have the object-oriented in other programming language. Okay, so we will look like a sneak peek only for other programming language. Okay, and then the last is working with object. So you need to know what is object. Okay, so let's guys, if you can help me finding out who is the one who keep unmute their self, and you can still hear, right? Okay, so at the end of this lecture, you will be able to understand the basic of OOP. Okay, object-oriented programming, we have a short form, OOP. We call it as a OOP. And then with the object attribute as object scripts, okay, that is the learning outcome. So I hope you guys can understand, okay, based on what you will learn today. Okay, so then object-oriented programming in general. What is actually object-oriented programming? So OOP is also known as, okay, object-oriented programming also known as OOP. So it's a programming paradigm. Okay, so it's a revolve around data structure that we call objects, which consists of states and behaviors, and the interaction between them via the message passing. So this message and variables are the two main kind of abstraction that used in the OOP. Rather than we write a set of procedure to manipulate members of each data type, the behavior become part of the data itself. So this makes many kinds of program, particularly ones involving simulation or graphical interfaces, easier to write. So in our situation, okay, in our situation, our object-oriented programming more to like a cloning. Okay, it's a clone. Clone is like more to the object-oriented in our situation. Okay, so next. Okay, so object-oriented, we have two object-oriented programming. One is the traditional form of object-oriented, which is the class-based OOP. So the class-based OOP, it represents a type of everything is an object. everything is an object. So object can communicate via message. This message usually handled by the method. What is the method in your program? Is the custom block. Custom block in our situation is our method. Okay, in Snap, in BYOB, or in Scratch. So custom block is our method. So each object have their own state. So every object is an instance of a class that will describe its instances behavior. So this is the class-based OOP. And then we have the prototype-based OOP. Classes are not necessary. Classes are not necessary. That's why I say in BYOB or in Scratch or in Snap, your classes, okay, your classes is your object. So your sprite can be classes. Your sprite also can be object. Because why? Classes are not necessary in our prototype base. Traditional one, classes is a must. Object is a must. The traditional form that use the traditional form, the class base is like C++, Java. So that is a class-based OOP. But in our situation, okay, in our situation, we are using a prototype-based OOP. So instead, okay, using a class, we use object to extend other objects. We call their prototypes, and variables and method may be added to any object at any time. Of course, guys, when we have the lesson of theory, we don't understand. Oh, what is this? What is the classes? Don't worry. I will show you the example. I will show you the example at the end of the class. Okay. So if an object does not understand a message, the message that you send to them, so it is automatically delegated to its prototype. So there are two methods of constructing a new object. First one is object creation from nothing, or you through a cloning an existing object. For example, we use BYOB and Snap. Why I never mentioned Scratch? Because previously, Scratch don't have this OOP. Previously, Scratch doesn't have this OOP. That's why I didn't mention Scratch. Not because until now, okay, until now, even you use a Scratch, you need a lot of steps, okay, a lot of steps to create an OOP inside the Scratch. Of course, I will teach you how. Don't worry, during the tutorial, okay? So, Snap, okay, any question for the first part? Do you have any question? Is everything clear? Because you can unmute yourself, right?
Clear, miss.
Any questions?
It's clear, miss.
Okay, clear, good. Okay. So let's we look into what is classes and what is object. Okay. Classes and object are the basic concept of the OOP, which revolve around the real-life entities. When we say classes and object, it revolve, okay, around the real-life entities. I will show you example. Okay. So class is a collection of similar objects. For example, I have animals. Animals, okay? Inside that animals, I have dog, I have cat, I have duck, I have chicken. Okay? So animals is a class. Okay? Animal is the class. So the object that's the object is that satisfy the class definition of a particular class are said to be an instantiate of the class. So I have a class animals. This one I give you example vehicles lah. Okay. Animals after this I show you example. Okay. I have a class vehicles. Under vehicles, I have the similar objects that belong to under vehicles. Okay, the instances. Because we said that object is something that satisfies the class definition of a particular class and said to be instantiate of the class. So, class vehicles. What is the object of the vehicles? Motorcycles, car, lorry, bus, and what else? What is belong to vehicles? What else, guys? What else belong to vehicles? I think I need to open Microsoft.
Airplanes.
Huh?
Airplanes.
Aeroplanes. So it's vehicles as well. So that is an object for the vehicle or instances for the vehicles. Okay. So that class vehicles is the class. So the other object like aeroplane, car, motorcycle, bicycles, that is a vehicles. Okay. Trains. Correct somewhere. Okay. Okay, correct somewhere. Doing theory is hard to understand. Correct. Later when I give you the example tutorial, I hope you will understand. Skateboard. Skateboard is not vehicles. Skateboard is more to, I think it's more to toys, right? Skateboard is not a vehicles. Okay. Okay. Next, I give you a more example. Okay. Animal, class animals. Okay. So inside the animal class, we have the instances where object for dog, cat, and cow. Okay. Dog, cat, and cow. Okay. So all these three can do it. They have a size, they have the age, they have the color. So this is the method. Method, or we can say is a function. Okay. So this is a method. This is a function. Guys, you can unmute if you have a question while I'm explaining this. Okay. Okay. You need to what we call it, unmute yourself. Okay, unmute yourself. You need to unmute yourself so I can explain to you guys. So this is the attribute. Okay, breed, size, age, color. So this is the attribute of our object. Okay, dog, cat, and cow. Okay, so this is the method. Okay, method or function. So we can call it as behavior, the behavior of our object. So similar to us as human. Okay, so as a humans, our parents is our class. Okay, we are the object of our parents. So we have a size, we have an age, we have a color. Okay, that is our attribute. But our behavior, how we eat, how we sleep, how we run, how we walk, how we talk, how we sit, it can be different even though we have a same parents. Just like you and your sibling. Maybe the behavior, the way or the style you eating with your sibling, okay, maybe your younger brothers or maybe your eldest brothers, okay, elder sibling, different. Maybe you like to eat Western food, but your sibling don't like. They like to eat the traditional food. Okay, the Malay food, Indian food, Chinese food. So that is your behavior. The behavior can be different. Okay, the behavior can be different, but you still have the same it. Okay, you still have the same method eat, but what happened inside it? The method eat or the function eat, it will do a different task because different behavior. Clear? Is it clear?
Clear, miss.
Is it clear with the class and object? Any
Yeah,
question?
it's clear.
Clear. Eh? You know what? When I teach the object oriented, I like to use our human being as our example, as our animals, because these examples are like humans. We are humans, so we know what is the attributes, what is the behavior, so we will understand more. Okay, what is the attributes in our class, what is the behavior in our class, same as animals. Okay, we tend to have our own pet, so we know that our pet will breed. Okay, they have a size, different size, they have an age, different age. So let's say you have two pets, two different pets, one is cat, one is dog. So they have different breed, they have different size, they have the age. Then the way they eat different, the way they sleep different, the way they sit different, the way they run different. Dog run faster, cat run slower than the dog. So even though they have a similar attribute name or behavior, but they will have a different task to do. Based on their, of course, based on their behavior, based on the attribute, based on the class itself, based on the object. Okay. I hope clear. I can proceed to the next slide. I can proceed to the next class. Next slide, guys.
Yeah, you can proceed.
Okay. Okay. So what is the OOP concept and terminology? Okay. So this one is based on our visual programming, guys. So script can create interesting and complex action for the individual sprite, but we often want to have many sprite. Yes, one sprite doesn't show that it's a good program actually. It will be like a normal tutorials, right? So obviously, you don't want to create a specific sprite for each entity, especially if you have a games. And 50% of you, okay, creating a game, a shooting game, okay, in which there are thousands of characters. When you create a games, you will have 1,000 of character, or maybe hundreds of character, or maybe 20 or 30 character. You don't have only 2 or 3 characters. For a shooting games, you have only 2 or 3 characters. That is not a shooting games, guys. So you need more than 3 characters or 3 sprite for your games, especially for those who are creating a games. And what saves us with this kind of many sprites that you need, many characters that you need, that is the fact that many items will share a similar structure and set of action that they can perform, especially the enemies that you want to shoot. The enemy that you want to shoot, they hold a similar behavior. And you will write a similar code for the whole enemies. So when you think about this interesting game, okay, you will have 1,000 or tens or hundreds okay, of character that you must keep track of. So what you can do, in addition to this character, we also need to have other items such as weapon, okay, such as building, such as maybe you want to change a clothing, you want to change you ask them to choose a different characters, maybe you want to draw a trees, okay, that will also you need to keep a track. So in this style of program design, you can do it nicely by having it in object-oriented programming. Actually, you already done it half object-oriented programming, because in visual programming, when I say method, it's a custom block. You already learned this week, so you can make them into a custom block. So you already learned part of it. Just you didn't learn the clone part. The clone part, don't worry. You don't have to revamp everything. As I teach you every time, do not revamp everything. You use the same code that you already done. You just adjust a small part. Editing a small part only. Okay, so that is the concept and the terminology that we had in the object-oriented. Okay, if you have thousands, hundreds or tens of, okay, your sprite or your character, use object-oriented. But actually you already have done. Okay, okay, so object-oriented programming usually organized around classes, which are programming elements that share certain characteristics. So classes might represent things that you could potentially see, like characters in an animation, players or weapons in the game, or bigger program components such as your background also can use as a classes. However, classes can also represent more abstract things, non-visible things like fraction or matrices or student lists. So objects are specific the instances of a class. So in visual programming, we consider that sprites are a class. Okay, even though just now I say in the prototype programming, it doesn't mean that you must have a class, but usually you will have a parent. Parent means for your enemies. You must have parent enemies that you can have the child enemies. So other enemies that having the same attribute, having the same method with the parents. You do the cloning. Okay, and when you create a specific sprite such as Alonso, you will have just created an instance of the sprite class. So for example, you have I always saw this as an enemies in the shooting games. This one, okay, or this one. So then, no, usually this is the shooting weapon. Okay, so sometimes like I saw something like this one. Okay, so this you will have multiple similar enemies. Yeah, you have more than one the enemies. So make one as a class parents, okay, and then the other will be a child where they will inherit the behavior and the attribute of the classes. Okay, I will show you how during the tutorial, so don't worry. Okay. Oh, I just want to check with you guys. You will end your class on 18, right? Means 22 lah, 22nd of October. So after that, is a study week or direct to your exam?
Revision week.
It's a study week lah, revision week. Or you have 1 week for study week or revision week. Okay. Okay, I'm thinking of something. Okay.
Excuse me,
Okay.
Miss. When will this semester end?
Your semester, your class will be end on 22nd week of 18 of October, week of 18 October.
Okay, okay.
We already in week 10. Okay. Okay. So we proceed. Okay. So when we have the class, we usually do with the constructor, constructing the object. So constructor we use for initialize a new objects. We fill, okay, the fields are variables that provide the state of the class and its object, and methods are used to implement the behavior of the class and its object. So every object can contain attribute and methods. Don't worry. All these I will give you example. Okay. So when we say attributes, attribute is like variables. A variable that associated with one object. While method is the function. So it's a custom block. Okay. In our situation, it's a custom block. Okay. Or a script that causes an object to perform some action. Okay, a method can access or change the attributes associated with this object, or it can perform some other action. That's why I say, just now we have animals. Animals, we have method eat. Inside method eat, we can have a different action. Like dog different. Dog eat dog food. Cat eat cat food. Chicken or maybe chicken or maybe fish. Okay, that is what cat eat. Cow eat grass. So different. Maybe the way they talk. Okay, if you have a animal talk, how they talk? Dog is woof woof. Okay, the action different. Cat will be meow meow, and cow will be moo moo. Different talk. Even though they have the same method, but the action is differently based on their own behavior, their own action. Okay, a special kind of method that we call a constructor. This one, special kind of method, constructor. Okay, defines. See, I put it in the wrong position. Sorry, guys. Okay, defines the action required to initialize all of the attributes of an object. So when an object is created, it will create variable for all of its attribute. And just like any variable, all this should be initialized. You should be initialized. You need to initial. Okay, all these attribute variables. So clear.
Clear, Miss.
Okay. So here we go. Object-oriented in other programming language. So there are several different styles of object-oriented programming. Like in Java and JavaScript, okay, it's a common programming language. Even though they have a similar names, but they are different, guys. Java and JavaScript are totally different. But okay, and they support distantly different style of object-oriented. Okay, C++ also is a common programming language that have a object-oriented. Okay, so BYOB or Scratch or BYOB or Snap, okay, support a particular style of OOP called prototype-based programming, in which new instances of objects are created by cloning an existing object called the prototype. Using a Snap is much more easier doing the cloning. Using the Scratch, using Snap, easier to do the clone. Just we have a lot of steps in BYOB to make a clone. I will show you in a Snap, because they, like I mentioned, Snap have a lot of new features that helping us in easiest our works in writing the visual programming. Okay, So one of it is the object-oriented. So this is example from Java. This is Java. So this is class name stack. Oh, sorry guys. Sorry. Okay. This is my eraser. Okay. So this is class name. Class name. Okay. So this is method or function. This is the statement that we do in the show message method. So this is class as well. This is the method main. We need a method main to run our program. So this is our call method. Okay, we call method, we call show message and test. And inside the same class new method, we have another new method class. We have a test method. That's why the way we call the method different. If the method is inside the same class, we just call the method name test. But if the method that show message is in different class, we need to call the class name static class dot show message. The output will be test the method. Okay, this is the output. Okay, because we call based on the first one test. Test method is the test the method. And then static class show message. Then they will have hello, my friend. So this will be the output. So here we go, class and method. This is how you call the method in Java. Okay, in Java. Clear?
Yeah, miss, clear.
Okay. Example, another one example. So this is we have class, my class. This is more to, this one is JavaScript. Public dot integer my num is a attribute integer variable, and string my string is the attribute for string variables. Okay, different. Okay, it's different. Okay. So object-oriented in visual programming. Sprite are a good example of object. Okay, it can be directly referenced, assigned to variables, and passed into function or the method, the custom block. You guys can take a note as well, custom block, or you guys can view the recording. Okay, but I'm sure, okay, you will be boring to hear my voice. Okay, Sprite can have local variables, which is the instance variables. The local variables, instant variables that we had in our snap. Later I will show you. Okay, in the tutorial. Okay, objects. Okay, and the custom block, the method. So objects communicate with each other either through the public broadcast or through the polymorphic message. Okay, through the public broadcast or through the polymorphic message. That you can do. Okay, the object can be communicate with others. So polymorphic is a polymorphism lah. Okay, it's a polymorphism. So it's a single single interface with a different types. So that is the polymorphism. Okay. Okay. Okay, so when we working with object, you can find this in BYOB or in a snap. Okay, you can find it in the BYOB or snap. If you go to your snap, I need to open my snap. Sorry, guys. Okay, if you go to the snap, you go to the sensing. Okay, you go to the sensing. Oh. Okay, you go to the sensing. Okay, when you go to the sensing, you can find the attribute. You guys can find the you can find the object. Okay, so this object is for yourself or stage or sprite. The one that I show you example in front there. Okay, in the slide is from the BYOB. So different in the BYOB and Snap, they separate different. One is object, one is mind. So you have neighbor, self, other sprite, clones, other clones, part, anchor, stage, children, parents, temporary, name, costume, all these inside mind. This mind is the attribute in the what we call in the BYOB. So this is the object that what we had. So you have the object and we have the mind. So you can use either object or mind. Okay. So if you want to look detail, you can right click and go to help. Okay. You can right click and go to help. So this is report the properties of the sprite and its families. So this is the attribute for the object that we had. So if you want to know about another sprite, you can use them inside the command. Of course, I will teach you. Okay, so you can also check the object. Okay, the definition of object. Okay, so this one is to report a name object. How many object you have? So right now you have sprite and stage. Myself. So that's why you have myself, stage, and sprite. So that is what you have. Okay, so different they just make a different command in BYOB and in a snap, but actually they have a similar things. Okay, so working with object, you can go to the sensing categories. Okay, I will edit. I will not edit. I will add a slide. Okay, I will add a slide. One with BYOB, one is from the snap. As in Scratch, we don't have. Okay, so it's inside sensing under attribute, then you will have a long list menu. Okay, this is the standard attribute that are part of any sprite. So this is the things that you can work with your object. Okay, clear? I will add another slide pages, and then I will re-upload the slide. And guys, one with a snap example, one with the BYOB. Okay?
Okay, miss.
Okay. So don't worry. When I re-upload, I will delete the previous one. I will just upload the new one, so you don't have to worry about that. Okay? Okay. So next. So more on object. I give you more example. Okay, so one of the key features of object-oriented programming are the notion of subclasses and inheritance. If you realize, I already mentioned about the inheritance, inherit from the parent class, okay, the child class. So child class always refer as a subclass. Parent class always refer as a superclass. So classes are often specialization of other classes. For example, what I give example game, because every semester students will create a games. a different type of game. But this semester, I say no shooting game. 50% of you giving me a shooting games. So when you give me a shooting game, make sure you make something different. Something that show that is your work, or you are finally remixing and reusing other people's works, not getting 100% other people's works. And usually why, okay, I saw a lot of you are using Scratch when you are using when you are creating a shooting game. I know why. I know why you are using Scratch, because Scratch giving you a lot of example in shooting games. So that's why I will ask you, request you to do something different. It's not that I not allow you 100%, but something different, guys. Something different. It's something that we can get that is not your work, that with other people works. So it's a plagiarism. So you can create shooting games. Some of you, okay, some of you creating something like they combine 2 different games into one games. So you can do something like that. You can do something like that. Do not just, we don't have to make our idea in a small part only. Don't cram the idea. Explore. Explore. Okay? Okay. So, for example, a game. Okay? A game might have an enemy. So, when you have an enemy, it's not only one enemy. You will have more than one. So, you will have enemies such as alien, zombie, or dragon. All these enemies will share or might share the same attribute, like the health value. When you shoot the enemies, the health value of the enemies will decrease. Okay, but there are also a specific type of the attribute for your enemies, like the enemies will disappear, or maybe that one when you shoot aliens, the enemies will be disappear. But when you shoot zombie will not disappear. Zombie will become more powerful. So that is the difference between that enemies. So these all enemies, alien, zombie, dragon, is a subclass. A subclass of enemies. So they inherit all the attribute, which is the health value. They inherit the health value. Okay, but they also have their own attribute, like alien will disappear, zombie will become more power, dragon will become more bigger. So that is the different type of, okay, attribute that they can have, even though they are inherits, okay, health value from the enemies, the super class. Just like you lah, I mentioned just now. Your parents is the super class. You are the subclass, which is the child class. You inherit their, okay, maybe their colors, okay, maybe the way they walk, okay, maybe the way they talk, you inherit them. But you have your own attribute, right? Okay, the way you eating difference, okay, so that is the attribute that you can have differently from the parents. Maybe the size, maybe our parent is small, we are bigger, so that is the different attribute. Okay, clear?
Yeah, I understood.
Other student, clear?
Yeah, clear, miss.
Okay. So, another example is you and me. lecturer and students, but we don't have any attribute that can relate or create a relationship between us. But we can define one classes named person. So lecturer is a person, student also is a person. So from that person, then we can create a relationship between the students and the lecturer. When we create an information, APU create an information system for the university. So they have a classes of lecture and the class of students. But class students and lecturer cannot have a relationship directly until you be assigned to a program. Like you guys, engineering and CT. So you will have a relationship with me as a lecturer because I'm teaching IT module or CT module. So you need to take this module. So that is the relationship between us based on the program. Clear? Clear, guys?
Yeah, clear, miss.
Okay. So another good example of abstraction in computing that we can define a sequence of subclasses that get more and more detailed and specific. And at each level, we can mostly ignore the details that are hidden in the super class. Okay. So this is terminology, the term that we will always use when we go to the object-oriented programming. The first one is attributes. Attribute is the variables that are associated with a specific object or sprite. Child object, so an object that is created by cloning a prototype object in prototype clone object in clone. Okay, the original object is known as the parent object and the new object is a child object. Okay, so a class is a general class of object. Individual objects are instances of some class which defines the common characteristic of the class. Okay, like weapon, monster, and etc. Constructor, a script that is run to initialize various attributes in a new object. Inherit, the process by which a subclass includes the attributes and method of its superclass. Is the relationship between a subclass and its superclass. Method is a script that are specific for a particular object or sprite performing action on or for that object. OOP is a programming style to design, that is oriented around defining programmatic objects in terms of the attribute and methods. Please take a note. Object-oriented programming has many other aspects that beyond the scope of what we have learned. Okay, Snap, BYOB, we have like very limited of the object-oriented programming. But when you go to other programming language, you will have learned more than this. Okay, more than this. Okay, so parent object is an object that creates another object by cloning. So in cloning, the original object is known as the parent object and the new object as a child object. Prototype, an object that is defined so as to serve as a template or model of object from a particular class. Prototype-based programming, so this is a OOP in which new objects are created by cloning a prototype object. Subclass, a class that is specialization of another class. Superclass is more general class of two classes related to the is a relationship. Okay, so I'm not sure if we have this in a snap. Okay, we can go and check first whether we have this in a snap or not. I think we have We can check. We have run, we have lunch. Okay, we have the call as well. Okay, we have all these three. So it's not BYOB lah. Okay, it's not BYOB anymore. Okay. So this is a, we can say it's a visual. Okay. Okay. Every sprite should have one and only one green flag script. If you notice, guys, during this week tutorial, even though each sprite having the green flag click, but they did almost similar things that will not having a confusing or interaction to the program to run. It's not that in the first sprite, when we click a green flag, they do different tasks. So it will be difficult. So BYOB allow you to have more than one green flag in one sprite. But it will be very easy to give you a conflicting instruction or to count on one being executed first. That's why we use the procedure broadcasting and receiving. That is why we use the procedure, because we want to avoid that we had multiple green flag click or multiple start like space key press in one sprite. Okay, but BYOB as well or Snap provide a blocks for running script in parallel and running script that belong to other sprite, which is run. Run, they will take a command script as its input and carry out the instruction, while launch identical to run except is identical to the run here. Okay, is run and launch, this one similar. Okay, except that it calls the method as a separate script, so the calling script can meanwhile do something else. Run, they will run one by one. Okay, while call will take a reporter or predicate blocks, the one with this block or this block. Okay, this block. Okay, the one with this block or this block. Okay, this is reporter, this is predicate as input and return a value that can be stored in a variable or used in a condition. Okay, so let's we check. Okay, the snap. Let's we check the snap. I show you so you can have a more clear. Okay, so a run. Okay, we look at run first. So you can always right click and check the help. So this is run. Just make it bigger. Okay. So this is run. So it will run a command script. So for example, you have the script. So this script make this custom block I equals to 1. Okay. I equals to 1 to 10. So it means that I is equals to 1 and less than 10. So when you run the action, so the action will be run the block whatever you put in this slot. Action is your block. Okay, this action is your block. So inside your block, your reporter block, you have this script. So whatever you have inside this, they will run. So they will run the command. Okay. And that is run. While launch. Okay. Launch, you will run another script independently of the script. So the move and draw the script, when you launch, they will draw the script. They will run parallelly with the next script that is launched. So if run, they will finish first, the one that we had inside here. Then we will do after that. But if launch, if you have another script after your launch, they will do it parallelly together. That is the difference between launch and run. Okay. Call. Okay. For call, it will call a reporter or predicate block. So you can use either block that you create or the block that you have inside the palette here. Okay. We will use during our OOP tutorials. This one we will use during our OOP tutorials, so you can see. So you guys can see the difference. Okay. Okay. So we have 5 minutes breaks. We have 5 minutes breaks, guys. Before I show you example of your of the OOP. Any questions before I start the break? Any questions? Any question before I start the break? Any questions?
No questions, miss.
Any questions?
Oh, no questions, miss.
No questions. Okay, so I give you 5 minutes break. If you want to, I think 10 minutes is okay lah. I give you 10 minutes. Okay, 10 minutes. So if you want to go for a prayer, for those who need to pray, you can perform your prayer. For those who want to go for a toilet break, you can go for a toilet break. I give you 10 minutes before we come back. Okay, and make sure once you come back, open your snap. Open your snap. Okay, 10 minutes. So 5:45 we will start again. Okay. Okay, welcome back. Are you guys ready?
Yes.
Is everyone in front of your laptop now? Is everyone in front of your laptop?
I'm here.
Yeah, I know Ashfa will be in front of the laptop. Okay. How about others? Okay, so everyone here, eh? So let me start, guys. The one that I will show you is just a very simple one for started, eh? For the okay, to have a clone. Okay, we want to create a clone. So we change the sprite costume first. Okay, we remove this one. Okay, that's we have a sprite costume. You can have any other costume. Okay, you can have a different costumes. You doesn't mean that you must follow costume that I using. Okay, the one that I'm using, you doesn't mean that you must use that one. I would like to use airplane, okay, but it's still stuck here right now. We need to wait for a while. Okay, can we click here? Cannot. I need to wait for a while. While we are waiting, you guys please choose your own sprite. Okay, you already know that I will choose an aeroplane. You also can use your own sprite. Okay, you can choose your own sprite if you want. Okay, so this is my sprite. Okay, this is my sprite. Okay, I choose aeroplane. Okay, so I will have when a green flag click. Okay, I will create a clone. So creating a clone can be found inside here. Can be found inside control as well. So we create a clone of myself, the sprite. Okay, and then I will have the sprite that we want to have is to inherit the Y position of its parents. Okay, that will draw something on our in our screen here. So we have a forever first. Forever. We will draw something. We will move 2 steps. This time around, our step will be very small. 2 steps and turn down. Turn up. Turn down. Very okay, turn down 2 degrees. Okay. So when you click a green flag click, this is what you get, a clone. Okay, a clone. Okay, and this is what you get, the clone. Then go back to when. Okay, control when. Okay, we have the when I start as a clone. Okay, we go to variables. We inherit the Y positions, and we will have a pen down. Okay, then we will repeat until we touch. Okay, we will repeat until we touch the edge. Okay, we touch the H. So we have an H, and then we will change the X by 1, not 10, by 1. Okay, so you can try. This is what you can get. Okay, but since you use forever, once you use forever, what you can do is you can push them to stop all. You have stop this script, stop this block, stop all but this script, stop other script in Sprite. So you can choose stop all. Okay, when you you choose stop all. When you play, they will stop. Okay, when you play, they will stop. That is something that you can do. As you can see, they repeatedly, because we didn't have the clear. So you can have a clear. So they will just clear. So they will stop. Sorry, forever. It's a 2 degrees, guys. Why I make it 152? So this is what you will get. That's why, that is why we have a repetition like that. 2 degrees. I said 2 degrees, but I wrote 152 degrees. Good, Miss Azia. Okay. So this is what the one that will change as a clone. Which one is a clone? Which one is the clone, you think? Which one is the clone? Which one is a clone?
The one that is drawing.
The one is? The one that is?
Drawing.
Drawing. Okay. The one that is drawing is the clone. Okay. So this is your clone. So they will draw something like a curve. Okay. So they will draw something like a curve. So this is the clone, the one that drawing. Because if you didn't create a clone, okay, if you click, this is your aeroplane. The one that you create a clone, okay, the one that drawing, that is your clone that do the drawing. So if you want to make your aeroplane or your sprite become into a direction, a nice direction, always put the point in direction 90 degrees. So you will have this. Okay, they will be in a 90 degrees position. Why suddenly doesn't want to? Okay, let's wait. Okay. Because when we touch the edge, it doesn't do. See, when you touch the edge, it doesn't do. That's why it stopped, because we said that repeat until the touching edge. So that's why just now, if you click, it doesn't do anything. Okay, so that is why. Because we say that when we touch the edge, this is the edge. So you can choose either touching the edge or touching the color. So you can also touching the pen trails also can. It's up to you. Okay. So if you have something like you say that, Miss, I want to have a move, but when they touch, it will game over. So use a touching, guys. Use a touching command. You can have a touching color or touching the edge. Edge mean the when you have a square, they will edge. Okay, when they touch the edge, not the center of the square, then they will stop. So this is something that you can create very easy using the create a clone of myself, and they will do start a clone. But if you choose create a clone of sprite, what happened? What happened when you choose to create a clone of sprite? Actually, it's similar lah. Okay, because you only have one sprite. Okay, you have only one sprite. If you have more than one sprite, so example you have one sprite, another sprite, you have a sprite 2. So when you say create a clone of sprite 2, okay, so this when I start as a clone must be inside your sprite 2. So here we go. I didn't copy wait okay, done. So this is your sprite. They will do. Okay, they will do. But they didn't create. Okay, they didn't create the curve because the curve is based on this. That's why they will be like a line, straight line. So this is when I start a clone. If you have a different sprite, but if you don't want, you delete. It will be only in one sprite. Okay, so I need to change here myself, and then we'll do. So this is your sprite. Okay, any question regarding this sample?
No questions from me. It's clear for me.
Others, any questions?
No question, miss.
No questions? Is it clear for now?
Yeah, miss.
Clear.
Clear, miss.
Clear, miss.
I was not asking is it very clear or not because it's still at the beginning, right? Okay, it's still in the beginning. You still just learning, okay? So if you can see, we have this inherit. So we want to inherit which position? So we choose when you see when you don't have any things, you don't have any value to inherit. But when you already have the clone, okay, you have a lot of things to inherit. So for example, you say that X position. For example, you choose X position. You can see the different. See, nothing happened. Okay. So if the size, costume, volume, balance, so you can, if you inherit the script, what happened? Nothing. Okay, it's nothing happened. So if you choose size, also nothing happened. Okay, this program is for the purpose of the Y position. That's what we will get the curve. So you can try to see what happened, okay, when you inherit. So if you go to the control, you will see a lot of things that you can clone. A new clone of myself, okay, a create clone, delete this clone. So you can also delete the clone, okay. You can have this like this. When I start as a clone, delete this clone. So nothing will happen because you already delete the clone. So you also can have this. So maybe you can have this one put. At the end, you will delete the clone. So once you have done, you will delete. See, once you have done, okay, once you have done, it will delete. Okay, once you have done, it will delete. But this one will keep repeatedly moving, which is not good, guys. It's not good. Okay, that's why we have this stop all to stop the script, because when you have this repetition like this, it shows that your program doesn't terminate. Your program doesn't terminate. That's why we put stop all. If you put stop this script, only this script will be stopped. Only this script will be stopped. See? Okay? Okay, now you stop. Okay, stop this block. Okay, you stop. Okay, you check, and how to use this function. So when you choose stop all, everything will be stopped. Okay. Okay, because it's touched the edge, then that's why it will stop lah, because we say that touching the edge. Every time they touch the edge, it will stop. So to be easier, you can choose a costume. You can try to use this costume. This costume, because it doesn't touch the edge, it will keep repeatedly until touching the edge, then stop. You see the difference. Stop while touching the edge. Okay. Yeah. Thank you, Saad. Thank you. Okay. Any other questions? We're ready to roll. Drive. Any other questions? Okay, all clear? Then let's we give you the attendance. Okay, I'll give you the attendance. I will stop the recording.